Hey folks, we're going to look into MPLS in this series of videos. We look into a lot of fun things in MPLS, but in this video specifically, we'll start with like a brief overview, and we'll also look into the MPLS unicast routing. Okay, so before we get any deeper in MPLS, I want to probably take a few minutes to go through the history of MPLS. Why did we even design MPLS, right? Great. So let's put probably three routers here, right? Let's say R1, we have R2, and we have R3 here. Okay, all are directly connected, and we have the network, say one network here, the two network here, and the three network here. This is probably your 12 directly connected network, and this is your 23. I'm just using numbers so that I don't have to write the whole IP address. Okay, now let's try to construct the routing table, right? On my R1, I have my directly connected routes, which is 1, and I have my 12, right? Probably the interfaces, along the interfaces 0/0, this is 0/1. Here on R2, I have my 12, 23, and 2, right? So I have my 12, 23, and 2, right? This is again, maybe on 0/0, this is 0/1, and this is 0/2, right? And the last one is R3, so we'll have the 23 and 3 here, right? 0/0 and 0/1. Now let's also assume that we have an IGP working, right? Let's say EIGRP or something of that sort. Now because of IGP, R1 will also learn the other routes, not just a directly connected routes, but probably 2, 23, and 3 as well, because via IGP you can do that. So you have 2, you have 23, and you have 3, right? All the three routes are learned via IGP, right? Probably the next out for this is going to be R2, the R2 and R2, right? Because R1 is going to learn those routes via R2, right? Being the next out. Now on my R2, similarly, it is going to learn about 1 and 3, right? It's going to learn about 1 and 3, and 1 it is going to learn via R1, and 3 it is going to learn via R3, right? And the other one on R3, we are going to have 12, 2, and 1. Do you agree? Right? So we're going to have all these three routes. This one is going to be learned via R2, this one via R2 and R2, right? So this is the routing table, or you can say basically the RIB, right? Routing information base, right? So I constructed this table because I want to show you guys. Now what we'll do is, let's assume that we have probably a small PC over here, right? A PC which is probably 1 dot right, let's say it is 1.1.1, right? So we have this, and from here you're trying to do a ping to what you're trying to do a ping to probably the 3 network right here, right? 3.3.3.3, you're trying to do a ping. Okay, so how does this work? How does the ping work? So on PC, right, the packet, let's try to draw the packets. Okay, let's try to reduce the size of this. Give me a second. So that we have everything on the same. Okay, so what we'll do here is, let's try to see what happens on my on my PC, right? So on my PC, right, let's try to build a small table here. The source and destination will be 1.1.1 and 3.3.3. That's fine, right? The source is going to be 1.1 destination, but here what PC does first is, PC will do an ANDing operation of 1.1 and 3.3, and it figures out that obviously these both are not in the same network. So now the packet has to be routed to the default gateway. The default gateway for PC is this interface over here, right? Over here. So let's say this one is 1.1.10, right? So it has to route that packet to R1 now. Now you know the IP address. So if you know the IP address and you want to find the MAC, you need to do an ARP, right? So PC does an ARP and figures out that the L2, this is the L2 header, right? Here you need to put the MAC of PC, and this will be the MAC of R1, right? Great. So the packet has arrived on R1 now. So on R1, what we do is that, let's say we are trying to reconstruct, right? This will be still the same 1.1.1 and 3.3.3, but here on R1 first, it will look into the destination, right? The destination was 3.3.3, so it will look at its routing table. And if you look at the routing table, right, you have this route in your routing table, right, with the next stop being R2. Okay, so since the next stop is R2, it will now sorry, take this, right, since the next stop is R2, so it first did a L3 lookup, right, it first did a L3 lookup over here in the RIB database, and then now once it knows that the next stop is R2, it will have to do a it will have to figure out the MAC address of R2. So once it does ARP and figures out the MAC address, it will fill up the L2, it will do a L2 rewrite here. So this will be the MAC address of R1, this will be the MAC address of R2, right? And at every hop, this basically continues. The same operation happens at R2 and R3 as well, right? But what you need to notice here is that at every hop, we first did a L3 lookup, right? We first did a L3 lookup, we looked into the routing information base, right? We figured out the next stop is R2, and after we figured out the next stop, we did a L2 rewrite, or we figured out what is the L2 MAC addresses which we need to fill in the packet, right? So this process of doing routing is basically what you call as process switching. This is, let's say, switching, right? This process, it's a very old legacy way of doing it, legacy way of switching packets, right? So that was process switching. It wasn't fast enough, clearly, because you have to do like 2 lookups at every instant, right? So people thought, how about we make this faster? So to make this faster, what people did was, they said, now anyway, when the packet first comes in over here, right, when the packet first comes in, we do a L3 lookup and we then do a L2 rewrite, right? How about we store this information for my subsequent users, right? So they created what you call as a L2 cache, right? And this L2 cache basically had the information, like for example, for the network 3 network, right, the next stop is, I'm basically building the L2 cache on R1, right? So they built a L2 cache saying that for the 3 network, right, the next stop is basically R2, so my source MAC is going to be R1 and destination MAC is going to be R2, right? Similarly for the, they started building this L2 cache, right? So for the first packet, basically we will still do a L3 lookup and L2 lookup like we did in process switching, right, when the first packet comes. But once we have done the whole process switching for the first packet, we are going to store that information, right, in a L2 cache for my subsequent users, right? And that was basically your fast switching. Okay, that was your fast switching. People were still not happy, right? They wanted to make it more faster, so they went and kind of let me just raise the size of this. Sorry. I'm just getting used to my whole stylus thing, so this is a little tedious for me. All right, anyway, so yeah, so like I said, they were not happy with the whole fast switching. They wanted to make it more faster. So they thought, how about we don't wait for the first packet to come in, right? Even before the first packet comes in, let's build a table. Let's build a table with all the information which we need, right? So that now we don't have to do the whole L3 lookup, right, in order to figure out, or we don't have to even wait for the first packet. So between process switching and fast switching, what we did was we thought that we'll wait for the first packet and then build my cache. But in the next or I would say the next version of this is basically your Cisco Express, right, switching, right? Cisco Express switching. So this was supposed to be the fastest. It's also called as Ceph, right? You would have heard about Ceph. So this is your Ceph. So what you do here is that you build a table called forward information base, FIB table, right? Forwarding information base, and this FIB table will have the information, right, saying that okay, if you want to go to the 3 network, right, your next stop is your R2, and your source MAC will be your R1, and your destination MAC will be your R2, right? So you pre-construct, or you proactively construct this, because you have all the information, you know the routes from the routing information base, and you also have from the L2 cache, right, or basically using the ARP, you can figure out what your next stop, what are the MAC addresses of your R1 and R2 as well. So you can actually proactively figure out all this information, and you can prepare, and you can keep this information well in handy, right? So that is your FIB, or that is your Cisco Express switching, right? Ceph, right? Now when a new packet comes in, what we do is we still check the IP address, but we check it against the FIB table, right? We don't check it against the RIP table, we check it against the FIB table, and the FIB table will provide the necessary L2 max which you want for doing the L2 rewrite, right, on your packet as it is forwarded to the next destination. Okay, so this is basically the history. Now people did not stop here, right? So we did a lot of we started with process switching, we came to fast switching, and then we did Cisco Express switching as well, right? But like I said, people were again not that happy. They wanted to go ahead and make this let's say, delete this, we don't want all of this, let's just get rid of this as well, this one, right? So now we know that we are where are we have reached the whole we have reached the Ceph, right? But like I said, people were not happy. They wanted to make this even more faster, right? Now, like I said, in my Ceph, what we are doing is we are still looking up, or we are doing a lookup against my FIB table. Whenever a packet comes in, we check the destination IP and we check it against the FIB table, and based on that we do the forwarding. Now when you're doing a check of FIB, right, we are basically looking for 32 bits, because an IP address is 32 bits, right? Because you're looking at the IP. Now they said that how about we kind of like create an alias or a shortcut for each of the route in my FIB table, right? And they said instead of looking for 32 bits, we'll create a alias, right? An alias for every IP address, right? And that alias is going to be just 20 bits, right? So now instead of looking up a IP address which is 32 bits from your against your FIB, you're going to start looking only for a 20 bit field, right? Now the difference between 20 and 32 is just 12 bits, right? Now it might look very small, but this 12 bits actually constitute to 37%, right, of your 32 bits. So as a result, you can actually achieve, like if you're reducing this 12 bits, if you're removing this 12 bits from your IP address, you can actually achieve a faster switching of 37%, right? So they wanted to improve this. They wanted to improve the whole Ceph process by 37%, and they thought, okay, instead of using an IP address, right, in my FIB table, let me start using some, let's as an alias or a shortcut, right, or tags, right? So that's how MPLS was born, right? By now you would have understood that MPLS is all about routing using some tags or labels, right? So that's why you say it's a label switching, MPLS, right? Great. Okay, so now that we are here, what we'll do is, let me show you the topology which we have picked up, a very simple topology, right? And we'll not be looking at all the routers here for our discussion. We'll be taking into account only R1, R2, and R3 and R4, right? So I have a small screenshot of my use here, right? So which means we will start with R1, and we will use only R4 only till here, right? Only this is what we are going to use for our discussion, right? And what I've also done is I've actually put EIGRP here in this particular section of the network, right? So I put EIGRP over here, which means if I go on to my let's say I pick up my R4, and if I do probably show IP route EIGRP, right? Because EIGRP is very easy to build. Let me show you the configuration for EIGRP. I think that will be useful. Show run, if I do show run section and router, right? A very simple configuration, right? I'm just advertising my loopback network and the directly connected network, right? And if you do show IP route EIGRP, right, you will basically get to, oh my bad, or maybe on R1, if I do show IP route EIGRP, right, you get to see all the other networks, the 2, 3, 4, and right, the 23, 34. So this was basically what we discussed earlier, right? In my earlier, I had put a very basic topology and I had explained. So this is the routing table or the RIB basically, right? Here as well I can show you, right? You can see end to end from R1 to R4 we have the routing working, and on R4 you can see my D routes, right? These are basically the EIGRP routes which I learned. Okay, now all of that is good. So what we'll do next is, you have to understand MPLS properly, how the label switching works, how the label, you know, exchange, just label exchange happens, right? We need to actually build a routing table of our own, because that will be very helpful, right? Just remember this is our topology, right? Or maybe let me, I already have it here. Yeah, I have it here. So this is good. So I'm just going to put up, you know, the routes here. This is going to be the one network here. Here you have the 2, here you have the 3, and you have the 4, right? And you have the directly connected 12. Here you have the 23 and you have the 34. Okay. So I'm just going to start building the routing table, right? So we'll start with R1 here. Okay. Probably increase the size a bit. Not visible, yeah. So this is good. R1. So on R1 we will we have the directly connected route, which is 1, right? And let's put it C over there, right? We have the 2 network, right, which is learned, right, via R2, right, because R2 is the next hop. It is learned via obviously the you know, EIGRP, right? You have the 3 network as well, learned again via R2. What else? We have the 4 network, learned via R2. Okay. Then we have the 12 network, which is directly connected. I'm gonna put that. Okay, my bad. This is supposed to be R2. And what else? So we have the 23, which is learned via R2, and the 34 network, right? So I'm trying to reconstruct my whole routing table. Make sense? Let's come down and do the same thing for R2, or maybe, yeah, we can do it here, right? So for my R2, what I do is, right, so on R2, let's do the same exercise, right? So on my R2, we have the 1 network, which is learned via R1 clearly, right? The 2 network is directly connected, so we are sorted there. 3 is important, just learned via R3. Let me quickly do this. 4, and that's learned via R3. The 12 network is directly connected. The 23 network is directly connected, and the 34 is learned via R3, right? We just have 2 more to go, which is my R3 and R4, right? R3 and R4, like 2 more tables remaining. Let's do that. So on my R3, what do I do? On my R3, I have my 1 network, which is learned via R2. 2 is again R2, right? And 3 is C, and 4 is R4, right? Learned via R4. Then you have the 12, 23, and 34, right? 12 is basically directly connected. Oh, my bad, sorry. The 12 network is not directly connected. It's learned via R2. That makes sense. 23 and you know, the other one is directly connected. So 23 and 34, if I'm not wrong, is directly connected. Great. We have the last one, which is 4. Now it's getting a bit tedious. So 2 is R3, and what else? Let's do the 3, which is again R3, right? It's learned via R3, right? So it will be the next hop. 4 is directly connected. Let's do 12, which is, what is 12? Is it R3? Yeah, it is R3. And 23, we need to have 23, which is, yep, R3, right? 23 is via R3, and the 34 34 is directly connected. Okay, there you go. So we have done the whole the whole routing table here, right? The R1, R2, R3, R4, we have all the 4. Now, like we were talking about MPLS, the whole idea of MPLS is we are going to start assigning labels, right? So these labels are 20-bit in size. You need to remember that. So they are the labels are basically 20-bit in size. Let me write that down here, right? So the label is basically 20-bit in size, and that is the reason we are basically using it. They are smaller than the IP addresses, and as a result we're able to get that speed, right, which I explained earlier. Because they're 20-bit in size, 2 power 20, we can get close to 1 million labels, so you'll never go short of them, right? Now out of this labels, 0 to 15 are reserved, right? So we start from like 16, right? So 0 to 15 are reserved for some other purposes, okay, which is fine, right? So what we'll do now is we'll start assigning the labels, okay. Now when I said assigning the labels, we'll start assigning the router itself locally starts assigning the labels, right? So we have sorry, so we'll have like local label, right, which is going to be probably we'll start with 16 for this one, right? Similarly for the other route, it's going to be 17, right? I'm going to use sequential, but it need not be sequential and need not start from 16. I'm just using it can be anything, right? So I'm just using the easier ones here. So 18, 19, and you're going to have like 20, probably 21 and 22 as well, okay. So these are the labels which were locally assigned, okay. So you have 22 here. Great. So we have locally assigned the labels. So we did that on R1. Now obviously it's not just the router 1, even router 2 does it, right? 2 does it, 3 does it, and 4 does it as well. So let's quickly do that. Let's probably start, we can start from 16 here, but I'm going to start probably from a different number here so that I can show you a distinction of labels later, but it can totally start from 16 as well, right? Doesn't matter. Right here it's going to be 22, 23. Don't think that it has to be sequential for every single route. It can be anything. I'm just using it for the ease of using right now. 25, 26, and 27. Okay, there you go. So we are done with R2. Let's quickly do R3. And what do we use? We'll again start from 16, right? We'll start from 16, right? This would be 17, this would be 18, right? 19, 20, and 21, and the last one is your 22. Okay, so there you go. We have given the local labels for R3. The last one is my R4, right? So for R4, again, let's do the same exercise, but let's start probably from 25 here. 26 for this one, 27 for this route, right? So these are all routes, right? 7, 28, 29, and mind you, I'm actually talking about the fib here. I'm not actually talking about the routing table, but this is actually my fib table, right? But the fib table is generally the routing table in off late. That is, I mean, if you're not talking about a very legacy device, right? Because most of the routers now use your CEF, Cisco Express Forwarding, right? So we can interchangeably use the routing table as fib table, in my situation here. Okay, great. So we have what we have done now. We kind of reconstructed the routing table, or the fib table. You can say fib table or the routing table, right? And what we did was, for every of the route which is there, we have assigned the labels, locally assigned the labels, right? Now comes the interesting concept of the LDP, right? The label distribution protocol, right? Let me write that down. So what is that? It is the LDP, right? So LDP is the label distribution protocol. This is a protocol which is used to exchange the labels between the directly connected neighbors, right? That's important. So for example, R1 will send, like for example here you see you have routes, right? You have routes, you have R1 basically has a route for the one network, and the route is, sorry, and the label is basically 16, right? 16. And R2, if you scroll down, if you see here, R2 also has a label for the same network, which is 21, right? And you see in the diagram R1 and R2 are directly connected, right? So these both will start exchanging now, right? These labels will be exchanged, right? So this label, the label 16 here, right, when it comes to R2, it becomes the remote label for R2, right, for the same route, whereas the 21 basically goes up, right, and it becomes a remote label for R1, right? So that's what we are going to do now, right? So let me do that. Yeah, a minute, let me remove this. Yeah, so where are we? So what we are doing now is we are basically typing in the remote label for the network 1, which I learned from where, which I learned from R2, right? So, or maybe let's do the R2 first, right? That might be easy. So let's do remote here, and the label for the one network from the above table is 16, right? So we're going to put the 16 here, and a minute, yeah, 16. And how did we learn this? From R1, right? And the interface is Ethernet 0/0, right? Basically this interface, right? So that's how you learned it. Okay. Now we have to do the same thing for the rest of the routes as well, right? So when R1 and R2 are exchanging, they will exchange it. They exchange the labels for all the other routes as well. So for 2, you see it is 17. For 3, it is 18. This is 19, 20, 21, 22, right? So for all of the routes, they are going to start exchanging. So let me just copy this and let me start pasting it here. So for remote, right, the remote label for the 2 network is going to be 17, right? And for the 3 network, it's going to be 18, right? And for the next one, it's going to be, what is it? It's going to be 19. Do you agree with that? It's 19. Let's put the 19 here. And for the 12 network, it's going to be 20, and then 21, 22, right? We quickly paste this and then edit it. So this is 20, this is 21, this is 22, right? Just want to make sure that you understood this is. So you see here you have the local labels for 16, 17, 18, 19, 20, 21, right? These labels will be exchanged with the R2 because they are directly connected. R1 and R2 are directly connected. So for that specific route, right, R2 gets the label from R1, which is 16, right? And here you get 17, 18, 19, 20, 21, right? So you get all these labels. Now similarly, since R2 has got it from R1, the reverse process also has to happen, right? Do you agree? So here, this guy gets 21, right? Why 21? Because you see here, you have 21, right? Which is being used by R2, okay? And this would be 22, 23, 24, 25, 26, 27, right? Because the routes are same. So let's quickly do that. But okay, so this one I have to obviously edit and make it R2, right? So let me just copy this and paste it quickly. So this is going to be my 22, this is going to be my 23, this is going to be my 24, right? 25 and 26, 27. That's it. 26 is this, 27 is this. Okay, awesome. Now, so R1 and R2 have exchanged. Let's do the same exercise between R2 and R3, and then R3 and R4, right? So now when R2 and R3 are exchanging the labels, it's going to be, let's just do this. Let's do first on R2 probably, right? So we already have one remote label which we have received from R1, but we are obviously going to form LDP between R2 and R3, right? So we need to get the labels from R3 as well. So the R3 labels, you see, it starts from 16 again, right? So in fact, it's going to be exactly the same, right? The labels are going to be, it's only the next stop is going to be different. That's it. right? Probably it's going to be Ethernet 0/1 here, because you see, is it Ethernet 0/1 between R2 and R3? It's actually, yeah, right? So R2 and R3, it is connected to Ethernet 0/1 here. So that's going to be 0/1, which is good, right? So this is going to be the same. Let's just copy this. In fact, this is going to be 17. This is going to be 18. Hope you got this, right? What I'm trying to do is I'm trying to get the labels from the R3 now, right? For the same network. This is going to be 20. This is going to be 21. And the last one is your 22. Awesome. Similarly, R3 has to get it from R2, right? So, and you see the local label starts from 21 here. So let's do that. Right, it's 21, and this is obviously my next stop is my R2, and I'm learning this on the interface 0/0, right? If I take this, let me just put it up here, right? It's 22, and this is 23, right? So this process continues, right? We are going to do this for 24 and 25 here probably, right? And 6 and 7. 6 and 7. Hope this is good, right? So we have done the exchange between R2 and R3 as well, right? So every single router basically exchanges its labels with the neighboring router, right? As a result of that, we are able to build this database, right? And we'll quickly finish up the last guy. So we have the final exchange which has to happen between R3 and R4, right? So on R3, and you see on my R4, the labels start from 25. So clearly my remote labels here will start from 25. Paste it here. This is 25, and I'm learning it from R4, right? And what else? Learning it from R4, and along which interface? 0/1. So 0/1, yeah. Okay. So let's do that. So let's take this. Let's put it here. 25 becomes 26. 26 becomes 27. Here 28, right? 29, 30, and 31. Okay. Hope this is clear. And the other way around, R4 learns the labels from R3, and the R3's local labels actually start from 16. So we will have to do it from 16 here, right? So this is going to be 16, learning it from R3, and along which interface it is Ethernet 0/0. Okay, let's quickly do this. So we have 17 here, we have 18 here, 19, okay, 20, 21, and 22. Okay, awesome. So we have constructed a table now, right? It's no more a RIB table or a FIB table, right? It is no more, it's a new table because it has all the labels, right? So what is this table? This table is actually called as the label information base, right? What we have done now is my we call it as label information base, right? We have still not completed MPLS, right? We are still in the process. We have just built the label information base. Right now, if you look at say R2, right? If you look at R2, because you have the labels, or R2 is forming neighborships with both my R1 and R3. So if you look at R2, it's a very good example here. If you look at my R2, right? If you look at the table or the lib table, label information base which I've created, if you look at my R2, you see something strange. You look at, for example, R2, especially for the route 1, we have learned two labels here. We have learned it from R1 and we have learned it from R3, right? But obviously R2 is going to believe this particular label which I've learned from R1. Why? Because this network 1 is actually connected to R1, right? Now if you see similarly for 2 network, right, it is directly connected, so obviously I'll take the local label into consideration. Now for the 3 network, I'm going to use the label which I learned from R3 and not from R1, because my 3 network is directly connected to R3. So what we are going to do now is construct another table which will finally have, right, the actual labels which we are going to use, right? Because the lib table basically has all the labels which are learned, right? And some of them could be good and some of them could be bad. Like for example, here for one network we learned 2 labels and one of them was good and this was the bad label, right? So now we are basically going to create a new table called as the, what is it? It's called the, let me put it here. It's called the LFIB, label forwarding information base, right? So this LFIB is a new table which will be constructed using what? Using the lib table which I have already created, right? Using this and the fib, forwarding information base, which I already have, right? Using that, because to make this decision I need to know, right? I need to know which is the next hop, right? For example, the one network, the next hop is R1, right? From the fib table I get to know that for the 3 network the next hop is R3, and based on that I can make a decision as to which is my good label and which is my bad label, right? So the next step, right, is basically constructing the LFIB table. So let's go and do that, right? It's very simple. So let's say we are okay, here let's say we are on R1 here, right? And we want to construct the LFIB table, right? To keep it very simple, what I'm going to do is I'm going to do it for 1, 2, 3 and 4. The rest of the directly connected networks I'm going to skip it. Otherwise the table, it's going to take a lot of time, right? So while constructing the LFIB table, we have the network, we have the local, remote, this thing label mentioned here, right? So I'm just, my bad, right? Then we will also have the next hop, right? What else? We'll also have the interface, right? So this is how the table actually looks. So for the network 1, right, what are we going to use? We are going to use the local label as 16, right? And the remote label, what are we going to use? It's going to be untagged. For directly connected networks, the remote label is always untagged. You just need to remember that, right? The next hop is directly connected. There is no next hop is directly connected, and the interface, this is basically loopback 0, right? Now the network 2, for network 2, the local label is 17, right? It's clear, very clear, right? From here, from this table, we are basically using this table to do it. And what is the remote label? The remote label for 2 is basically 22, right? And give me a second, yeah, 22. And the next hop is basically my R2, but from my fib table I can actually get the IP address of my R2. So what is the R2? It is 12.2, right? So that's why I'm telling this LFIB table is a combination of my lib table and a fib table, right? The learnings from both the tables are basically put here, and the interface from where this learning is done is Ethernet 0/0, right? So that's how we go and now construct for 3 and 4 as well. For 3, the local is basically 18, and let's put the remote as 23, sorry, 23, right? And the IP address is 192.1.12.2, because clearly we're learning it from R2. This is going to be the same, and the last one is 4, and it is 19. Here it will be 24, right? This is still the same. Let's just copy it from here, and this also is the same, right? There you go. We have actually finished the LFIB table for R1. Let's go and do this for R2 as well, right? So let's probably do it here, right? So this is my R2. I can probably copy this and then reuse it, right? So for one network, clearly I'm going to use 21 here, and this is basically going to be 16, right? It is not directly connected. It is learned via 192.1.12.1, right? The next hop is R1, and clearly Ethernet 0/0. It's learned via that interface. Okay, what else? For the 2 network, it is directly connected, right? So let me just clear this out, otherwise it might be confusing. Just clear this out, one sec. Oh, that's anyway the same. Okay, anyway, so for the 2 network, it's 22, and like I said, it is untagged because it's directly connected, right? and so I can put a C over here. For the 3 network, it's going to be 23, right? Local label, and the remote label is basically going to be 18. Okay, and let me take this, let's put it here, let's put it here, let's put it here as well. And for the 4 network is 24, right? The local label is 24 and the remote is 19. So we are done with 2 LFIP tables. What else? Let's go and finish off the rest as well. Just copy this and let me scroll down to, where are we? We want to do the next thing for R3, right? So you go to R3 and yeah, let's clear this a minute. Okay. This one, so where are we doing this? We're doing this on R3. Let me just delete all of this. Okay, cool. So the one network, if you look at the table, just observe this table, right? That is what I'm using. For the one network, the local label is going to be, wait, did I make a mistake? 2419 connected, and okay, this is a mistake. Okay, this was supposed to be loopback. It's directly connected, right? So it's loopback 0. Great. Okay, so for R3, go to R3 and the local label is going to be 16, right? And the remote is 21. Let me just do this first. 17, and it's going to be 22, right? And this is going to be 18 and untagged because clearly it is directly connected. And this is 19, and where is it? It's learned from 28, right? Next stop is going to be R2 for this one. So it's 23.2, right? And this is going to be the same for this one as well. This is going to be directly connected, and the last one is what? And the last one is learned via R4, right? And that is 192.1.34.4. The interfaces are Ethernet 0/0, again Ethernet 0/0. This one is the loopback because it's directly connected, and this is Ethernet 0/1. Okay, looks easy. It's actually very tedious to build this table. Let's do the last one, right? We're doing the R3. Let's go and finish do the R4 as well, right? Great. Okay, let's just clear this out. Right, so yeah, so my R4, for my R4 I start the labels, the local labels will be 25. Let's quickly do this. 25, okay, I think there is a mistake. Give me 1 sec. This is supposed to be local label of R4, supposed to be 25. Yeah, 25, but the remote is supposed to be 16. I think I made a mistake. Okay, this is good. Yeah, so this is 16. Okay, and this one is 26. This is 27. This is 28. Clearly, this one is going to be 17. This is going to be 18, right? And the directly connected ones is untagged. Okay, makes sense. This one was learned via R3, so we're going to do that. 192.1.34.3, right? And that would follow for this guy and this guy, right? This one is directly connected, and the interfaces are, okay, we could say Ethernet 0/0, right? It's actually Ethernet 0/0. Yeah, this guy. Cool. So let's put that. And this one is loopback 0. Great. Okay, that was really tiring to build the table, right? Anyway, but it's good now. We have constructed the LFIP table, right? We have constructed the LFIP table, which means we have actually completed the MPLS, right? Now using this table, using the LFIP table, let's see how a packet actually traverses through the network using MPLS, right? This is literally MPLS unicast routing, what we have achieved now, okay? So to do that, we will start by creating a packet, right? Let's start by creating a packet here. Give me a minute, let me just do the size of this. So let's say on R1, right, we are trying to do a ping. We are doing a ping to what? 4.4.4, right? Let me probably increase the size of this a bit. Okay, so we are doing a ping to 4.4.4. okay, so we need to have clearly the source MAC, right? We need to have the destination MAC. We need to have the label, right, where this label is going to be used. I'll show you that. And we also need to have the source IP and the destination IP. So this is what I'm going to use while explaining this example, right? So when you're pinging 4.4.4, right, and obviously there'll be data after this, which I'm not going to represent. So you have the 4.4.4 here, the destination IP. The source is 1.1.1 because you're doing a ping from R1. Okay, makes sense, right? Because R1 is here, right? And we're doing a ping with source being the loopback 1.1.1, right? So this is cool. This is clear. The destination IP, source IP is clear, right? Now what happens is R1 will look at the LFIP table. When it looks at the LFIP table, the destination is 4.4.4, so it will look at this particular. Let me highlight this, right? So what it will do is that it will look at the sorry, my bad. It will look at basically the this particular take the color here, right? It will look at this particular row, right? Because our destination is 4.4.4, right? And what we will do is based on this, right? We have a label here, right? The label, it will use the remote label. The remote label for this particular route is 24, so it will use the remote label here, right? And the MAC address, it would have already picked from the FIP table or from the L2 cache, right? I have not mentioned it here, right? But it already knows the MAC, because at the end of the day, what we are doing is we are doing CEF, Cisco Express Forwarding, right? And I have explained earlier that in Cisco Express Forwarding in CEF, we proactively have the destination MAC. We have done the ARP and we have figured out what is the MAC for a particular route, right? We have it stored in the router. So we're going to use that, and this one is going to be clearly the MAC is going to be R1, and here it's going to be R2, right? So this is the packet which goes to my from my R1 towards my R2. Right, now let me just copy this so that I don't have to repeat. Let me just copy this and let's go here, right? And this is on my R2. What happens on R2? Right, let's come down here. On R2, you see the IP addresses, all of these will remain same. But for the 4 network here, the remote label is 19, right? The local label is 24 and the remote label is 19. So it received a packet with a label of 24. So what it will do is it will just do a label lookup. Because I received 24, it will now switch this 24 with 19. And the MAC addresses obviously will be R2 and R3 because the packet is going to the next hop, right? So you see what is happening here, right? At every hop, we are not doing any kind of L3 lookup. We are no more looking at the routing table. We are actually looking just at my, we are just looking at my the label table, actually the labels. We're just looking at my labels. Now at R3 the same exercise happens, right? The label here which I have received on my R3 is 19. So for 19 you can see the remote label is 28, right? So I happily go and replace this with 28, and this is going to be my R3 and this is going to be my R4. What happens now? Let me take this. At R4, what is happening? On R4, again, the IP addresses all remain same, right? But on R4, I have received a packet with the local label of what? 28 now, right? So you can see the remote label is untagged. So the first action, what is going to happen here is, it is going to pop the label, right? So this label is gone, It's going to pop the label, right? And it will look up the routing table, and it will basically, because this route is directly connected, right, it will look up the routing table, or let me have a look here, right? So first it looked up the LFIP, right, and it popped the packet, because it popped the label because it is untagged here, right? Now once it pops the label, what is this packet is an IP packet, right, because there's no more a label, right? There's no more label, which means the packet is just an regular IP packet. Now for a regular IP packet, how do we route the regular IP packet? We look at the FIP table, right? And we look at the FIP table, and it because the destination is 4.4.4 and it's directly connected to R4, right? This is the data will be delivered to the router, or basically the packet will be delivered to the interface to which it is assigned, or to which it is supposed to go, right? So this is actually R4, right? So if you observe carefully, what has happened on my let me just show you what has happened on my R4, right? On R4, what has happened is, first we had a lookup against my LFIP, right? And we found that the label is untagged, so that's why we popped it, right? We removed the label, and then once the label was removed, it became an IP packet, so that's why we had to check our L3 database, or the FIP table, right? We had to do a L3 lookup to figure out where to send this packet, or which interface to send this packet to, right? So we had like 2 lookups happening here. Now this number can be reduced. Instead of doing 2 lookups, we can reduce it further to 1 lookup, right? So that's the concept of penultimate hop popping, right? So in MPLS, instead of popping the label on the last router like R4, we do it actually on the penultimate router, which is R3, right? Which means all our the change has to be now incorporated into my LFIP table as well, right? So what do I mean by that is, this is how it is, right? If you look at the topology here, let's take a different color just to show that. So if you look at the topology here, you see there is network 2 here, right? The network 2 is directly connected to R2. So for this particular network, or for this particular route, when the label is sent towards my R1, when R2 sends the label to R1, it will send a pop label, right? So if you look here, right, so this is my R2 and the local label is 22, right? So when R2 is exchanging labels with R1 here, right, for this particular network, instead of sending 22 here, it will actually send a pop label, right? So the directly connected networks, you always send pop labels to your LDP neighbors. So for 2 network, right, for the 2 network, R2 sends pop label towards R1 as well as towards R3 here as well, right? So instead of sending 22, it will actually send pop label, right? Which means the whole our LFIP table, we'll have to edit it now, right? So let's edit it. Like for example, R1 is here. This is the LFIP table for R1, right? And you can see that R1 is connected to R2 and R2 is connected to the 2 network, right? So for 2 network, the remote label is going to be pop. It won't be 22, rather it will be pop, right? Because that is what R2 would have actually sent. I did not want to bring this up earlier because I wanted to show you what happens if you don't do, if you don't use the concept of pop, right? So that is the change here. Now coming to my R2, you see R2 is connected to what? R2 is connected to R1 and R3, and you have 2 connected networks here, which is 1 and 3. So we'll have to do pop for 2 guys here, right? Which is my R1 here, pop, and R3 as well. There will be a pop, right? That is for that. Oh my bad, I think I did it on the wrong one. Sorry, supposed to do it here. Just do Control Z and remove that. Okay, yeah. So I'm supposed to do pop here and pop here, right? Similarly, R3 you see is connected to R2 and R4. So you'll have to do pop here for the directly connected network, which is R2 and R4 as well, right? Hope this is very clear. Now on R4, you see it is connected to R3, right? R4 is clearly connected to here. If you see here, you have R3, which is R3 is connected, I mean the 3 network is connected to R3, but then R3 and R4 are LDP neighbors. So on R4 you'll do the POP for the 3 network, right? So here instead of this we do the POP, which means now if you see here what happens is that, let's redo this, let's redo what happens on R4, right? Or in fact what happens is on R3, instead of doing a label swap, right? So R3 received this particular packet. So where is my R3's LFIP table? Here, right? And for the 4 network, right, this is my LFIP table for the 4 network. Now it has received a packet with the label of 19, right? Now instead of doing a label swap, you do a label pop here, right? So the label gets removed from here itself. So on the penultimate hop, the label gets removed. Because the label is removed here, this packet is what? This packet is clearly just a IP packet now, right? This is just a this is just a IP packet. Now because this is an IP packet, right, and this IP packet is obviously now forwarded, this packet now arrives on R4, right, and we don't have to do the LFIP check at all on R4. So on R4 this packet appears as an IP packet, and we do just the L3 lookup on R4, right? Getting the whole idea? So that is the whole idea behind the MPLS unicast routing, right? So just to recap, let me just delete all of this and put the whole let me just take this picture once. I just want to tell you what happens at different stages, right? So we did a ping just now. We did a ping from 1 to 4, right? We did a ping from 1 to 4, and right here we actually created a labeled packet, right? We created a because we did a LFIB lookup and we created a labeled packet, right? Here what we did was we did a label swap, right? We did a label swap, right? We got an input label, or we got a based on the LFIB table, we figured out what is a remote label, and we did a label swap. Here we did label pop, right? Because the 4.4.4, right, for which we were trying to ping is actually directly connected to R4. So that's why we did a pop here. This is basically the concept of penultimate hop popping, right? And the packet which comes here is basically an IP packet, right? So we don't have to do a LFIP lookup, we just need to do a L3 lookup here, right? So without doing pop, what we figured is if you don't do the pop, we'll have to do 2 lookups on the last router. So to prevent that, what we do is in MPLS, we always pop the label on the penultimate hop router, right, PHP. We do it here, and as a result you just get an IP packet after popping the label, which means you have to do only 1 lookup on the last router. Okay, so that is basically your MPLS unicast routing. This is the whole fundamental of your MPLS unicast routing. Okay, yeah. Now what we'll do is we will actually configure this, right? Till now what we did was we were just looking at the MPLS theory of it, but the configuration is actually pretty easy, right? You don't have to, though the concepts seems little complicated, but the configuration is actually pretty simple. So what we do is we go to R1, right? Let me clear the screen. We go to R1, enable, we go inside, we do MPLS LDP, right? The router ID, we need to give a router ID for this, so we can normally give a loopback interface itself, right? And the interface where we have to enable MPLS, right? That's important. We need to enable MPLS now. So we are looking at R1, R2, R3, R4. So just this interface Ethernet 0/0, right? That's the interface on which we will be enabling, right? So we do MPLS IP, right? This is basically for the LDP protocol to work, right? That's why we need to do this. So we did that on R1. Should we do that on R2? Yes, we have to. So now we go inside R2, enable configure mode, MPLS LDP, right? Router ID is loopback 0, right? Interface 0/0 and MPLS IP, interface Ethernet 0/1, right? We do that on MPLS IP here as well on both the interfaces, right? You can see the LDP neighbor come up. Let's do that on R3 and R4 as well. Let's clear the screen. And after doing this, I will be able to show you the tables which we earlier built on our own, right? LDP, we enable MPLS, sorry, enables LDP router ID loopback 0 and interface same concept, right? Ethernet 0/0 and 0/1. 0/0, we do MPLS IP, enable it on that and enable it on the other interface as well, /1, and do MPLS IP. Okay, and the last one, the fourth router, R4, sorry, enable configure T, right? Interface Ethernet 0/0. My bad, wait, I think I did not enable this before. MPLS LDP router ID loopback 0, interface Ethernet 0/0 is MPLS IP, right? And yeah, I think that's good. Just on one interface we have to do, because R4 we are just talking about this section of the network, right? So there you go. So we have enabled MPLS throughout the network, which we want. Now if you go probably to R1, and if you want to see all of that labels and all of that, I can show you that. If you do show MPLS LDP bindings, right? There you go. So you see, you can see this is the lib table which I was talking about, right? We had constructed the lib table. So you can see for every network you have a local binding and you have a remote binding, right? For the two network you have the local, you have the remote, right? You can run the same thing on my R2 as well. So clear screen, right? You can see here on R2, because R2 is connected to R1 and R3, you might get multiple remote bindings, right? Because it is learning for the same network, it is learning from R1 and as well as learning from R3, right? So you have multiple remote bindings. So this is basically the LDP bindings which I was talking about, right? And now if I go to my if you want to see my LFIB, right? This was label information base, but if I want LFIB, which is the final table which my MPLS will be using, right? Here you go. This is the LFIB. So for R1 you can see the pop labels are here, right? Because the for the network, for the two network, right, we want a pop label, right? Because it is directly connected, because R1 is directly connected to R2 and R2 is directly connected to 2, right? As a result, R2 sends a pop label towards R1, and that is why you have the pop label here. It's the same case for this network as well, because it's directly connected network, right? Between between 2 and 3, and R2 is directly connected to this network. As a result, R2 is sending pop label for this as well. In our discussion, we actually limited ourselves only to the loopback networks. As a result, we did not discuss this interfaces, but the logic applies here as well, right? And if you want to verify, you can verify as well. Whatever we discussed earlier in our tables, whatever tables we created will be in line with this, very much in line with this, right? The concepts are also very much in line. You can see the pop concept coming up here. Similarly, you can try out the other, you can do the same thing on probably R4 as well, right? You can see here on R4 you are getting the pop label for the 3 network, because the 3 is basically connected to where? R3, right? If you see here, R4 is connected to R3 and R3 is directly connected to the 3.3 network, right? As a result, R3 sends a pop label towards R4. Okay, so this is basically your MPLS unicast routing, right? We actually literally finished the whole unicast routing, how the labels work, how the lib table works, how the LFIB table works, and finally how the MPLS routing happens. So the prerequisite for MPLS routing is that you need to have your IGP first, right? The first step is you need to have IGP, any kind of IGP, right? Have some IGP so that the routing table is up to date. Once you have your routing table, right, ready, or the FIP table, right? I'm going to use this I'm going to use it interchangeably here, right? But you should have your routing table ready, and only then after that, when you configure MPLS, right, the labels will start working, and the labels will be assigned to the various routes in your routing table, and yeah, the MPLS starts working. And the whole idea, just to recap, why are we using MPLS? It's because we want to speed up the whole, routing switching process, right? We don't want every single router to go and check its routing table. Rather, do the lookup based on the labels, right? And that is quicker, right? So thanks for watching. This was a basic idea behind MPLS. Do watch the rest of the videos of the series coming up for more ideas on MPLS. Thank you.